All right, so now we've defined what an integral is all about. Let's talk about how we could actually evaluate an integral. So let's say that I have the integral from 3 to 5. These are called the limits of integration. These are our boundaries. So we're going to go from 3 to 5. We're going to go 10 minus 2x dx. Okay, and the dx is part of the notation here. We are integrating with respect to x. The 10 minus 2x is what we're actually using as our function. Okay, so because this integral is defined to be an area, if we have something like 10 minus 2x, okay, 10 minus 2x is a line that has a y-intercept at 10. And it goes down as we go to the right, crossing the x-axis here at 5. So if we are going to integrate from 3 to 5, what we're really looking for is this area between 3 and 5 that is bounded on top by 10 minus 2x and on the bottom by the x-axis. We know how to find the area of a triangle. We've known it for years. It's just 1/2 base times height. So to evaluate this integral, I can find the area here, 1/2 base times height. The base is just 2. And then the height is what this function is equal to at 3. Okay, so I would do 10 minus 2 times 3. Okay, 10 minus 2 times 3 is 4. So we're looking at 1/2 times 2 times 4. So this area is equal to 4. That is my integral. Okay, so the integral is, it's 4. That is the answer to that. That's the value, the quantity that the integral is. Okay, now, so this is great. This is a great strategy if you get a region that is something you know an area formula for, like a triangle, half circle, trapezoid. If you're doing problems out of section 5.2, that's how they want you to figure out what the integral is equal to. Determine the shape, use the formula that you've learned from a previous course, and then figure it out using the area formula. Okay? There's another way, though, that we can figure out this solution. The secret here to calculus, this is a shocking reveal right now, is the antiderivative that we were talking about before break. The antiderivative is actually the integral. I mean, so if I have 10 minus 2x here, the antiderivative of 10 minus 2x, for 10 it's just going to be 10x. Okay? And then the 2x, I'm going to go and increase the exponent by 1, so we're looking at 2x squared, and then I'm going to divide by that new exponent, so divide by 2, which gets me to x squared. So I have 10x minus x squared. And you might be thinking about, but don't forget the plus c, Mr. Tubby. You always say don't forget the plus c. Okay? Here's what we're going to do, though. We're going to take this, and we still have to deal with the 3 and the 5. Okay? So we're going to take each one of these numbers, each one of these limits, and we're going to put them into the antiderivative, and we're going to find the difference of the two values. Okay? So, first we're going to take the 5. That number doesn't always have to be the biggest number. Like I could have the 3 there and the 5 there. It would mean something a little bit different. The 5 is the first number that we're going to put in, though. So we're going to go 10 times 5 minus 5 squared. Always put that top number in first. Okay? Then we're going to do 3. We're going to put that in. We go 10 times 3 minus 3 squared. And then what we're going to do is find the difference between the two. Okay? So 10 times 5 is 50 minus the 5 squared. So we're looking at 50 minus 25. that's going to be 25. 30 minus 9 here is going to be 21. And if you look at it, 25 minus 21 is 4. It's a shocking result. It's exactly the same as you came up with when you used the area formula. It works. Okay? You get an answer here of 4. Now, granted, these problems can get a lot more elaborate and they can get more challenging to do, but this is the general idea, okay, of what you're doing. Taking the antiderivative, put that number in on top first, put the bottom number in second, and you're finding the difference between the two. You are also going to come across some integrals that have no numbers on them. They're called indefinite integrals. So let's say we have just an integral here of sine of x plus e to the x dx. No numbers here. When I have no numbers, it's just straight up the antiderivative problems that we did before break. Okay, so we're looking at sine of x. Its antiderivative is negative cosine of x. If I were to take the derivative of negative cosine, I get sine. Antiderivative of e to the x is e to the x. And here is our beloved plus c. Okay, so if there are no numbers on there, it is the exact same problem as the ones we dealt with before break that said find the antiderivative. Except there's no words here. It's just symbols. Okay? I know that I can't solve all of your problems from home and with my little whiteboard, but I can at least give you a little bit of instruction. If there are things that you still have questions about or particular problems that you're having trouble with, just write them in the comments and I will try and take care of them. Maybe I can do just some homework problems for another video. So hope you all are doing well. I'm doing all right. I'm hoping to be back and seeing all of you next week. So enjoy the rest of your day.